and also to be able to find the value of x here. So in this case, first of all, with scale factor, you compare two sides that you know and then just simplify it. So, so for scale factor, if you did that, what two sides did you guys compare? 24 and 20. So 24 goes with 20. Do you agree with him? That should not be 10. Yeah. So 24 goes with 20. You could also have used, you could also, oops, 24 goes with 20. It's not the same. Oh, I didn't do a good job of this one.
I was confused.
Sorry, this is a bad problem. Dang it.
What?
So they have to be the same. So, okay, so this might be a good, this is a good example of what's not proportional. So I said if we know these are similar, these aren't similar. So these should match up. So this is my mistake here. These scale factors should be the same. So if I simplify this is 12 over 10 or 6 over 5. If I simplify this one, it doesn't. So these two don't match up. All the parts aren't proportional. So these are actually not proportional. So we're not actually able to find the scale factor because they don't match up. That's what I get for adding a question quickly. I added these, so I thought we needed more examples of these, and I did not add a good one. So this is not proportional. All right. Good life lesson. All right, the next one, it says to determine if they're similar, yes or no, and then they want us to write a similarity statement and find the scale factor. So this next one, they want us to check if they're similar. In order to be similar, the sides have to be proportional. So we're going to check and see if they actually are proportional. Now this one's a little bit tricky because of the fact that nothing's marked for us other than the side lengths. And there's decimals, that's a little bit annoying. But one of the things I'm going to suggest you notice is looking for the longest leg should go with the longest leg, if that makes sense. So the longest leg in this one is 15, so that's the biggest number. What's the longest leg over here? 12. So I'm going to say 15 goes with 12 at this point. I don't know for sure this is the case, but we're going to go with that. I want that to be equal to another ratio. Someone give me another one. What should go together? 10 and 12.5. Now when I go to write that, how do I have to write it based off of how I wrote this one?
12.5 over 10.
Yeah, so 12.5 over 10. And then I want that to work with the last set of sides. Which one has to go on top? 11.5 and 9.2. Now just looking at these don't look like they work. How can I tell if they actually work? You can divide both of them, you can simplify them, or you can like rewrite them, figure them out as a decimal. If you divide them, like this one's really easy to divide. I move the decimal over once. If you divide 15 by 12, if you divide 11.5 by 9.2, I'm hoping it's 1.25. Is it? So that's one way to check. These all work. So they are proportional, so that means that the sides all match up. So this is what the last one was supposed to do. Now, I could have also, if you wanted to, you could also cross multiply, and they should be equal as well, so you can check it that way. That would also work, but I think the way that we suggested, just dividing them and checking and see top divided by bottom, it should work out. So they want a similarity statement and they want the scale factor. What they mean by a similarity statement is I'm writing the triangle is similar to the other triangle. So I'm going to call it NPQ. I'm going to use the squiggle for similar. And again, we're talking about a triangle, so I want to call it a triangle. Now, one of the things I do a lot of times with this is drawing these like circles and boxes. I don't do that just because I want you guys to see what I'm talking about. Well, that's part of it. But can you tell, if I'm talking about n, which angle should go with n based off the way I have it drawn? R, because of it's between the circle and the box, so it should be R as well. Then if I go down to P, so I go down the square way, I'd go down to T. And if you look at it, T is the obtuse angle, so that makes sense. And then obviously S would be last. Now, if you called something different to begin with, if you didn't call it NPQ, let's say you got crazy and changed the letters order, it's still, you'd have to make sure it matches up. So those letters have to go together. So this would be our similarity statement. And then the last thing is the scale factor. Which fraction would be easiest to use? 15 and 12. And simplify, divide them both by 3. So our scale factor would be a 5 to 4 scale factor. So kind of a lot going on in these problems, but at the same time, all I think pretty reasonable. Hopefully you guys are getting better with our proportions.
Do you get lunch earlier than
Today?
Yeah. So
Why?
we don't have to deal with lunch.
We have DLT time today.
I used to be sure.
No, study hall, like normal, like AR study hall, sorry. No, we have so.
And that's why I was always like, what?
No.
What?
No, I meant like AR study hall, sorry.
Holy Griffin's fault.
It is Griffin's, Lane Griffin. Alright, so this also works for other types of shapes. So they're telling us ABC, and that squiggle's kind of lame there, is similar to QRST. So when I do this, if it's helpful, kind of making some marks to kind of help me with this. So like A would go with Q. They kind of match up. At least this one, they're like drawn the same. Like B would go with R based off the name. And then like kind of go around, you could go, kind of helps a little bit if you want to do that, if making marks is helpful to you guys. Now, careful, the way they ask us, they ask what's the scale factor of QRST, so this is the little to the big. So this one's asking us to kind of flip that rule there. So little to big. What sides do you guys want to use to help us with that?
A, B, and Q ball.
Which one?
A, B, and Q ball.
A, B, and QR?
Yeah.
Okay. Now, since it's A, B, and QR, but they asked for the little one first, we're going to put 12 on top this time and 18 on the bottom. So depending on how they ask us to write the scale factor, they might ask you to write it in like upside down, maybe it feels like. But if that's what they ask for, we can divide those each by 6. So it's a 2 to 3 scale factor. So this one's basically 2/3 of the bigger one. They also want us to find the value of x. So we're going to set up a proportion to figure that out. So someone tell me the first part of the proportion they want to set up. There's lots of different ways to do it, so I don't want to like grab one and assume you want to do it that way. What do we think? Zach, how'd you start yours? Because I see you started it. What'd you do?
I put the window. Like, I made
Okay.
them equal those fractions.
So he used the scale factor. So you could either use the scale factor or you can use the side length. So he said 2/3. So little to big. If we're doing that, we want to find x. What does our next fraction have to be? Someone other than Zach, because he's got it. What does it have to be? Decker?
X over 12.
Yeah, so then if we start with small, we have to go this one compared to the one it goes with. So little to big, we have to go x over 12. Does that make sense? Now, this is not the only way to do this problem. You could have used 12 over 18. You could have used any of these sides, would have worked, as long as you match them up correctly. Now, a lot of people like using scale factor because the numbers are smaller. So cross multiply, divide, and we find out x is 8. And there's probably multiple different ways for you guys to get that answer, so I'm not saying this is the only way that works. Okay.
We do all these problems.
No, we're doing one more. one more together, and then then we're done for today. I said this is a 2-day notes sheet, but you weren't listening to me.
Homework the whole time.
And then the long, long homework, like Zach pointed out. Okay. What's it? No. Sarcasm. Yeah, it's pretty short. Yeah. I think some of them do have multiple steps, I think. I'm not sure. I might like. Oh no. Never mind. What do I have you guys doing for it?
5 to 10.
Oh yeah. Well, five is long because 5's like the first question we did where we have to do like write all those proportional parts, so it just takes longer, and I didn't need to do that a bunch of times. So, all right. So they tell us these polygons are similar. So again, I like marking things a little bit just to help me here. So like R goes with A. So like these two are the same. But I want to remind you guys what we talked about in the first part of this lesson. What do I know about the angles of similar figures? Do we set up a proportion for that? Think back to what I said about the angles. What? They're going to be what? They're going to be the same. So remember that angles are going to be equal. It's the sides that are proportional. And because if you try to set up proportions for the angles as well, you're going to be like in this big mess of a problem. So remembering this is super important. So if R goes with A, those two are actually equal. So n plus 7 is going to equal 70. So solving for the angles in similar polygons is actually very easy. Well, hopefully it's very easy. So n is 63. We got 1 down. We need n, m, x, and y. So we got n down. What do you want to go for next? M. So now for m, this is angle T. T should go with C. So those two should be the same. So for m, I can say 2m minus 4 is going to equal 66. Move that 4 over. Divide, and we find out our m. Okay. So again, angles are pretty easy with similar figures. We're going to go for x.
It's the hardest one.
Careful. So x should go with which side? CD. So TU, if you're unsure, TU goes with CD. Now remember, x and 3 are not the same. Did you write x is 3? It's not 3. They're proportional. So x is not as easy as just saying it's the same. So we're going to set up a proportion for that. So x over 3. So it's proportional, it's not equal. What else can I use to help me with this? 4 over 6. Now I would not use the y over 1 right now. That'd have 2 variables in one problem. So we're going to use this 4 and 6. Now if I wrote x over 3, how do I have to write it?
6 over 4.
The 6 should go on top because x and 6 are in the same shape. So x is the bigger one, so 6 is the bigger one. So that's one thing where you can kind of get yourself into trouble here. It has to be set up this way if that's how we started. Okay, so kind of trying to point out those little details that kind of can cause some issues. So we can cross multiply here. So we find out x is 4.5? Yeah. Okay. So we got our x down, and we're left with our y. Now it has y plus 1 on there, which is a little annoying. That goes with this 8. So I'm going to write my fraction of 8 over y plus 1. Those two go together. If that's the way I wrote my first fraction, how does the second one have to look? What's the second one going to look like, you guys? Don't be afraid to use something again.
6 over 4.
Yeah, 6 over 4. Why not use this again? We know that 6 over 4 is that ratio that works. Now 6 should be on top because 8 and 6 are in the same shape. So don't forget, it's okay to use that multiple times. Or if you wanted to be like really advanced, you could use 3 over 2 because that's 6 over 4 simplified. Is everyone okay with how we got that? So again, we can still use this. We've already used it. We can use it again. It's still the same ratio that works. Now careful here. Here's where our proportions are important. That 6 has to be multiplied by y plus 1. And 8 times 4. So 24. And so we move that over, so we find out y is 4.
I think it's 26.
Oh, thank you. It seemed too easy. It was. So y ends up being 4.3 repeating? Yeah. And so we found our y then. And so in that shape, it'd be 4.3 plus 1 if we did that. Okay? Questions there? All right, so you have the really long homework assignment. Use your time wisely, get that done. Reminder, this is already due tomorrow again.